Good day, viewers. We are going to continue with our subject matter of number systems. This will be our fourth video on this system, and we will do mostly on so we will be starting with exercise number 1.3 of the book. We have done some sums from that exercise, but we will continue doing the remaining one. And some of the major concepts on this area I will also be able to explain to you. So let us start from chapter number 1.3. Exercise number, not chapter number, and the one that we have not done the other time is 1.6, question number 1, and that is number 6, and that one consists of decimal expansion. So decimal cutting of expansion of 329 by 400. Okay, so how do we do it straight away? So let us do this. Decimal expansion means you have to long division, so you put a 0 here, so it's 80, so 8, 32, 0, 0, so this is 90, 90, because of this thing you put a 0 here, it becomes 2, so this is 800, then this is 100. Okay, so again 1 0 here, so this would be about, again there would be 2, again this would be 800, 800, so you get a 200 here, again you put a 0, so it becomes 2000, so this would be 5. So this is straightforward. 2 0 0 0, and this ends here. So this is a straight away a decimal expansion, and this terminates. So this is a straightforward question. Okay, then we have to go to the one here which says question number 4 we have to do, because question number 2 and question number 3 we have done. So let us do question number 4. So this becomes question number 4 is only one question. There is no subdivision on this question, this question, and let us do it this way. So this is question number 4. Okay. And the question number 4 says express 0.9999, and it is repeated how many times? 5 times. In the form P by Q. Okay, now if I have to do, and this does not end here, okay, it continues. So I can say, I can also write it 0.9 to the power bar, and this is this. Let us use our usual protocol of doing this kind of a sum, or usual procedure, whatever way you say it. So let us take x equal to 0.999. Okay. Again, this is 1 is repeating here, 1 is repeating here. So I will multiply by 10, 10 into x. So this would be 9.9. Right? I will write 9.9 as 9 plus 0.9. Okay? And you can easily see 0.9 is, you can write it is 0.9. So you can, okay, I can, in order to show continuity, I'll put another 1 and I'll put another 9 here. So it becomes easy for you to visualize. So this will be 9 plus x. Therefore, it should be 10x minus x is equal to 9. Therefore, x equal to 1. Interesting result. Please note this. Why it should become a 1? Because you see, as I go on all these things, the difference between 1 and 0.9999 continuing becomes very, very small, and it becomes very, very insignificant. And so this leads to a result of 1. Okay, now the next one is also a little bit interesting. This is very simple. Only thing, don't get scared that how do you get a question as a 1, because of this type of a question where you have repetition of 9. So you will land up at the end as 1. Okay. Now let us see another one. We will do it, and that is about number. Introduce the concept of co-prime. Co-prime. What is co-prime? What is, first of all, what is prime? Prime number is, you all know, which cannot be factorized. That means what? Prime number, say 23, say 17, say 3, then it is 5, then it is 7, right? 11. This cannot be factorized. So we call them co-prime. So co means what? It should be at least 2. इसी के साथ 2 or more than 2 or greater than 2. Okay, that one. So let us take our first definition about rational number. Rational number. What do we say? First of all, we said that it should be in the form p by q. So this is a factor. And we say that q is not equal to 0. So that means we have got 2 factors. So they should be co-prime. Now let us consider a factor 35 by 45. Okay, let's factorize both of them. This is 7 into 5 and this is 9 into 5. So both of them have a common factor, which is that 5 is a common factor. What do? We cut on both sides, and then we say this reduces into 7 by 9. Now we cannot reduce it further because there is no factor which is common to both of them. Okay, remember 7 is a prime, but 9 is not. But we are, because this can be factorized into 3 into 3. But we cannot do anything with it because there is no common factor. Because there is no common factor. Okay. Now, is that true? Okay, I think we have to change this concept a little bit. We say yes, it has a common factor, and that common factor is 1. So 7 into 1 into 9 into 1. So we can say that in such kind of cases, even though they do not have a factor, but they actually have a factor which is 1. They are divisible by 1. And so this position like this, which you cannot reduce a factor, or except 1, there is no other common factor. So they have except 1, they have no common factor. Is that all right with you? So when this kind of a thing happens, then we call it co-prime. So for our cases, for a representation on real number line, we should have these things in co-prime state. Co-prime state, we should bring it them. So there is no common factor except 1. Okay, now it says what are the these things properties should have. So let us write down our own properties, what we should need and what we should have. Okay, now first of all, when we have a fraction or 1 on the we have a denominator and a numerator. Okay, let us go from the basic. So I will again pick up the same example, 7 by 9. So 7 is numerator, and this is denominator. Okay. So this we know. We have been doing it since class 6, that we know when we have learned how to divide. So this is it. And here, first of all, this is in the form P by Q. And what are the properties of Q? Properties of Q होगा एक 1 property. So properties. क्या क्या properties हुआ? एक तो ये 0 नहीं होना चाहिए, ठीक है ना? 2, Q should be greater than P. Okay. Third, P by Q should be co-prime. Okay, once we know about these are the properties, we should be able to, this should be maintained in order to, and again, of course, there should be able to, can be expanded decimally. Decimal expansion should be there. So you can have decimal expansion. So you should have decimal expansion. और decimal expansion में क्या होता है? If I take decimal expansions, I can erase it again. Oh, okay, there is a space, little bit of here, so you can have a decimal expansion. और उसका क्या नतीजा क्या निकलता है? एक 1 terminate. Okay, no termination. But repetition. And third one I will write on the top. So here I will write on the top here, and this is again no termination. And no repetition. Right? So let us number them. 1, 2, and this is 3. Okay. 1 and 2, let us write from here to here. Okay. Termination. No termination. But repetition. These two would be rational number. So this is 1, what we have done, 1 and 2 will give you rational number. So again, no termination and no repetition. irrational number. This one should be irrational number. ठीक है? So this takes care of question number 7. Okay, now it says find 3 irrational numbers between the rational number 5/7 and 9/7. So question number 8. Okay, how do we handle this? It says irrational number, 3 different irrational numbers between 5/7 and 9/11. Okay, ठीक है ना? Then first of all, what will be my job? That convert this one into, so first job number 1 is to convert 5/7 and 9/7 and 9/11, not 7, 9/11 into their decimal expansions, right? Okay, so let us first of all do that. Okay, so first of all, if I do that, so I'll write down here 5/7 and 9/11, right? So that I can erase this portion. Okay. So 7/5.7749. No, not 7. 49. So 101730. 30 would be 4, 28, 20. It should be 2. So that will give me 20. That will give me 14. Then I will have 60. This is 6. So 60 and 8. So that would be 40. No, 56. Sorry, 4 will be remainder. 40. Okay, 40 again 0. Okay, and I will have now 5. So this is 35 and this is 5. So I started with 5. This was 5/7, right? So again 5 has come back. So that means this will keep on repeating now. So what will be? So I can put a bar on it. So let me keep this one aside. So this is 0.71425, and that is equal to 5 by 7. Okay. Now, what is the remaining? 9 by 11. Okay. I have to go through again the same thing. I have to go through by again for the same thing. Okay. Now let us do it here again. This, if you do this a number of times, you will get very good expertise in decimal expansion, which is very important. So you have 9 by 11. Check both. They are definitely co-prime numbers, so I don't have to worry about it. The other one also 5 by 7, they are also co-prime number. So do it this one. So since I am doing it, so 0.0888, so this gives me 20. I know this should be 1, 11, it comes out 9. It's very simple. Now it is easy. The 9 is again being repeated here. So this is, we'll keep on repeating 81, 81, 81 like that. Okay, now, so I can write 9 by 11, 9 by 11, this of course should be written as var, it's not, didn't terminate there, okay. So it should be 0.81, so this is var. So what is my next job? So job number 1 done. So what is next job? This is 3 irrational numbers. So first of all, I know that the beginning of first one should be greater than this one. So I can write 0.75120030060002. I can keep on writing. This is number 1. Number 2, I can write 0. Okay, now I will change this one. I will say, okay, this is 7, 6, 9, 4, 0, 0, 0, 2, 0, 0, 1, 2, 0, 1, 2, 0, 0, 2. So this is another irrational number. Third one, 0.7925 15329. I can keep on writing it. As long as this number does not become more than 0.81. So it should not be greater than 0.08. 0.81. Is that okay? So because you can keep on writing anything here. So these would be 3 irrational numbers. So these are 3 irrational numbers. That is done. Now we come to the next question, number 9, is relatively easy. So I will erase this. And this would be question number 8 will go, it will be 9. 9, 1. That is root over 23. What do you say? This would be irrational number. Right? This would be irrational number. We know all roots. All roots will be irrational number. Question number 2. Root of 2 to 5, right? Yeah. So what can it happen? So if I take 4, if I take 5, it should 45 into 5. Yes, 45 into 5. Let us do it further. So 9 into 5 into 5, right? So that will be, let us do it further. 3 into 3, it can be done very easily. 15 into 5 it will be. So 5 into 5. But suppose I don't know, I should keep on factorize. So this is going to give me 3 into 5, that is 15. You all know that 15 into 15 is going to be 2 to 5. So this is becoming a perfect root. So this is a rational number. No problem on this issue, and you know how to do it. If this is something which you do not recognize immediately, then you can do by this procedure. Now number 3. Number 3 is what? 0.3796. Now this is terminated. So this is a rational number. Decimal expansion, rational number. Why? Because the decimal expansion terminates. Right, this is done? Okay. Now let us see question number 4. Question number 4. Let me erase this one because I want to remain within the video's review, and it doesn't get. Okay, this is number 4. This is 7.478. Right? Now look at this. 478, it repeats. So even though it does not terminate, but it repeats. So this is a rational number. Done? Acha, last one, that's the 5. What is that? The number is 1.101001, then 10001, again 40, 1, 2, 3, 4, 1. So what is it? This is non-terminating, meaning non-repeating. So irrational, rational number. So I think we have completed chapter number 13 in all completion. It has been completed totally. And if you have any questions or any clarification, you can definitely reach my number, which is 940-751-8512. Okay, and from next time we will be taking up representing real numbers on number line. This concept I want to clear. Thank you. And I would like to take this opportunity to request you to like this video and as well as subscribe to my channel.